Hi, welcome to my video on Review 1, Solving Trig Equations with Cosine and Sine Ratios. And this is on videos 1 to 11. And this one can be treated as a quiz, marked out of 44. And as in all my other videos, you would mark each question. If you get it right or wrong, give yourself a mark, total up the page on the bottom, total up each page on the bottom. Then when you're finished, add up all the pages, put it over 44 and convert it to a percent. So let's start the review on those videos. Find a reference angle for each. Cos theta equals a half. What's the reference angle? Well, if cos is a half, then the reference angle is, you have a special right triangle. So if you put it, cos is a half in quadrant 1, which is where everything is always positive. Cos is the x, so if you put x is a half, then the y is root 3 over 2. Hypotenuse is 1. This point is 1, 0. Opposite root 3 over 2 is a 60. And the reference angle is 60 because it's the angle between the terminal arm and the x-axis. Sine is root 2 over 2. And the reference angle for root 2 over 2 is a 45. And again, every trig ratio is positive in quadrant 1. So if you draw the right triangle in quadrant 1, sine is the y. So if you put y is root 2 over 2, the x is root 2 over 2. Hypotenuse is 1, so opposite root 2 over 2 is always a 45-degree angle in both corners when you have a right triangle. So the reference angle is 45. Give yourself a mark each if you have those right. Find a reference angle for each to the nearest degree. Sine theta is decimal 2441. So you go the reference angle, so the sine of the reference angle is, you do that when it's positive or negative, and that means the reference angle is equal to sine to the -1 of 0.2441. You do that on your calculator and you'll come up with, let's see, sine of 2441. So let's clear it. Inverse sine of decimal 4221. And we get a reference angle, and 24.9 is 25 degrees. 25 degrees is the reference angle. Okay, give yourself a mark if you have 25. The cos of decimal 663, again, the cos of the reference angle is always when your decimal is positive, which it is here. So the reference angle is equal to cos to the -1 of 0.6663 and 0.6663. So if we do that in a calculator, inverse cos of 0.6663, and you get a reference angle of 48 degrees. Every time you keep your decimal positive, you're always in quadrant 1, which is where your reference angle is. So if you have 48, give yourself a mark. And the sine, notice is negative here. So the sine of the reference angle is decimal 7711. So now it's negative, making it positive, you're going to pick up your reference angle. If you did inverse sine of the negative, then there's not enough math done yet to explain why that works. So keeping it positive will give you the reference angle. So the reference angle is sine to the -1 of 0.7711. And that reference angle, if you work it out, becomes 50 degrees. Give yourself a mark. And the total for the page is 5. Hopefully everything is going well in the review. Number 4. Find a reference angle if cos theta is 1.42. So I'll use the calculator on that. And inverse, let's clear it. Inverse cos, because we're looking for the angle, 1.42, and the calculator gives me an error, and that means it's not possible. So find a reference angle. Cannot be done. So if you say cannot be done, give yourself a mark. And the reason why, because when we looked at the graph of cos at 0, cos was 1. Then it went back to 0, but down to -1, went back up to 0, like that. So here's the cos graph doing this. So the maximum for cos is 1. The minimum is -1. That's the x value. So we cannot have it bigger than 1. So that's why the calculator reads domain has an error, because the maximum, the domain of the cos is -1, is less than or equal to theta is less than or equal to 1. Can't be larger than 1, can't be smaller than -1, or in between those two. Give yourself a mark. Number 9, find the value of theta from 0 to 360 given the reference angle. So if I have a reference angle between the terminal arm and the x-axis, theta is this rotation, and so theta is 180 degrees minus the reference angle. So it's 180 degrees minus 30 degrees, so theta is 150 degrees on that rotation. Give yourself a mark. And theta here is all the way around, right on around until it hits the terminal arm. So this is the reference angle between the terminal arm and the x-axis. So theta in the fourth quadrant is always 360 minus the reference angle. So it's 360 minus the 45. So it's a reference angle is the 315. Give yourself a mark. And here we're in the third quadrant, quadrant 1, 2, 3. So theta is the rotation from the standard position at 0. This point is 1, 0. So we leave this point and rotate right around till we get to the terminal arm. Third quadrant, so the third quadrant is always 180 plus the reference angle. So that's 180 plus the 60. 60 is the reference, so that's a 240 degrees. Remember, the reference angle is between the terminal arm and the x-axis. So there's the reference angle. Give yourself a mark, total of 4 for that page. Hopefully you have everything going well. And number 5, remember, we're reviewing, the questions are taken from each of the videos in order. Find the value of theta from 0 less than or equal to theta less than 360 given the reference angle. And we're in the fourth quadrant, quadrant 1, 2, 3, 4. And theta is the rotation all the way around, right over to the terminal arm right there. So theta in the fourth quadrant is 360 minus the reference angle. And so that's 360 degrees minus 74. And 360 minus 74 is 286. And just check your calculator. 360 subtract 74. Sometimes you is 286. Give yourself a mark if you have 286 for that rotation from here right around to the terminal arm. And if you got 286, add on 74, gives you 300. Perfect. Number 6, find theta from 0 less than or equal to theta to 360. Sine is negative root 2 over 2, and you're in quadrant 3. Quadrant 1, quadrant 2, quadrant 3. Here's the terminal arm going out. And we drop a perpendicular to the x-axis. Remember, theta is this rotation from here right on around to the terminal arm. And so sine is the y. And in this triangle, this is the y. So y is negative root 2 over 2. Because there's root 2 over 2, automatically this angle is a 45. So your reference angle is 45 degrees. And also, this side is root 2 over 2, and is negative because x is negative in the third quadrant. The hypotenuse is 1. And so the rotation for the third quadrant is 180 plus the reference angle. So it's 180 degrees plus the 45. So theta is 225 degrees. And it's 1 mark for drawing the triangle, getting the correct reference angle, and 1 mark for the final answer, 2 altogether. B, cos is root 3 over 2, and you're in the fourth quadrant. 1, 2, 3, 4, fourth quadrant. Draw your terminal arm out in the fourth quadrant. Drop perpendicular to the x-axis. Cos is associated, or is the x on a unit circle, so the x is root 3 over 2. And because we have a root 3 over 2, then that means the other side is a half and a 1. But because the y is going downward, that half is a negative. But the angle opposite to 30 is, angle opposite a half is 30 degrees. The angle opposite root 3 over 2 is a 60. So there's the reference angle. So the reference angle is 30 degrees. In the fourth quadrant, theta is 360 minus the reference angle, 360 minus 30, and that gives me 330 degrees. And if you check your calculator and do the cos of 330, the calculator will give you, instead of root 3 over 2, 0.866, which is root 3 over 2. So you get 2 marks, a mark for getting the reference angle, a mark for getting 330. 5 altogether for that page. Continue. Number 7, find theta from 0 to 360, equal to 0, not equal to 360. Sine theta is a half, and we're going between 90 and 180. 0, this is 90 is here, 180 is here. So we're in this quadrant here, and sine is half. Remember, sine is positive, if you think about it. Add sugar to coffee. Sine is positive in 1 and 2, but we're only, yes, this is in quadrants 1 and 2, but we're asked to go to quadrant 2 between 90 and 180. So we draw our terminal arm in that quadrant. We drop a perpendicular to the x-axis. Sine is the y, so the y is a half. X is root 3 over 2, but is negative in that quadrant. Hypotenuse is 1. Opposite of half is 30. So the reference angle is 30. In the second quadrant, theta is 180 minus the reference angle, 180 minus 30. So theta is 150 degrees. And give yourself a mark if you have 150 degrees. We're put in a quadrant this time. And number 8, state the quadrants where cos is positive. Okay, that means I'm going to look at remember, cos is the x, sine is the y on a unit circle. So I could go where's x positive? So if we do that, well, I'm going to do this first. Add sugar to coffee, because these letters are telling me where the trig ratios are positive. All, sine, tan, cos. So everything is positive in quadrant 1. Sine is positive in quadrant 2. So if sine is positive, that means cos and tan are negative, etc. So cos is positive. Cos is positive in 1, guaranteed to be 1, because everything is positive in 1, and cos is positive in 4. And that's where x is positive. X is positive on the right side. Sine is negative. Sine is in terms of the y. Y is negative, and that's in. Sine is, y is positive on top when 1 and 2. So sine is negative in 3 and 4. Or sine, using add sugar to coffee, sine is positive in 1 and 2, therefore it's negative in 3 and 4. Give yourself a mark if you have these numbers. Cos is negative, cos is the x, cos is positive in 1 and 4, so cos is negative in 2 and 3. Sine is positive in 1 and 2. So what letter is repeated twice? 2. So the answer is 2. If you have 2, give yourself a mark. Quadrant 2 is repeated. Cos is less than 0. That means cos is negative. Less than 0 is negative. Cos is positive in 1 and 4, so it's negative in 2 and 3. Sine is greater than 0. That means sine is positive. Sine is positive in 1 and 2. And again, 2 is repeated, so 2 is the correct answer. Find the value of theta from 0 less than or equal to theta to 360, where cos is a negative root 2 over 2. Okay, so we have add sugar to coffee. Cos is positive in 1 and 4, so it's negative in 2 and 3. So it's 2 and 3. So we draw the terminal arm in quadrant 2, perpendicular. And with the circle, we draw the terminal arm in quadrant 3. We do a perpendicular. And root 2 over 2. X is negative root 2 over 2. But automatically, when you have a root 2 over 2, your reference angle is 45. Your reference angle is 45. X is negative root 2 over 2. It means that y is root 2 over 2, positive. And here, y is root 2 over 2, but is negative. So for root 2 over 2 is both sides with hypotenuse of 1. That means you got a reference angle of 45. So that means theta is, in quadrant 2, is 180 minus the reference angle. So it's 180 minus 45. So it's a 135. Give yourself a mark. And in the third quadrant, it's 180. Theta is 180 plus the reference angle. So it's a 180 plus the 45. And that's 225. Again, if you have 135 and 225, give yourself 2 marks. And if you want to check, do the cos of 135, and the calculator will give you a negative 0.707, because the calculator won't give you root 2 over 2 negative. It'll give you a decimal in terms of, so root 2 over 2 is 0.707. It tells you if you got it done right. And you do the same thing for 225. The cos of 225 will give you a negative 0.707, which is root 2 over 2. Add up your score, 7 for that page. Hopefully everything is going well. Number 10, find the value of theta from 0 less than or equal to theta 360, where sine is a half. And we got to get the values, so we add sugar to coffee. Sine is positive in 1 and 2. So we'll go to quadrant 1, and we'll go to quadrant 2. First quadrant, terminal arm, right there, perpendicular to the x-axis. And sine is the y, so the y is going up, root 2 over 2. The x is root 3 over 2. Hypotenuse is 1, opposite the half is a 30. So the reference angle is 30 degrees for both quadrants. And if we draw it in the second quadrant, terminal arm is out there, perpendicular. Again, the y is a half, so that's a half. Y is positive going up. The x is root 3 over 2, but it's negative in the second quadrant. Hypotenuse is 1. Again, you have a half, so the reference angle is 30. So in the first quadrant, theta is equal to the reference angle, which is 30 degrees. So if you have 30 degrees, give yourself a mark. In the second quadrant, theta is 180 minus the reference angle. So it's 180 minus 30. So it's a 150. Give yourself a mark for each of these. And check. Sine of 30 should be 0.5. The sine of 150 should be 0.5. And we have the cos of decimal 3131. So we need the reference angle. So the cos of the reference angle, and it is already a positive, so I didn't have to write this down, but I wrote it down. You have to have a positive decimal to get the reference angle. So the reference angle is cos to the negative 1 of 0.3131. So you take the calculator and you make sure it's turned on, you clear it. So it's inverse cos of decimal 3131, and the reference angle comes out to be 71.7, 72 degrees. So the reference angle is 72 degrees. And we have to go and find the quadrants. Let's do the two of them here. So cos is positive in, let's look up here. Cos is positive in 1 and 4. So this in quadrant 1, terminal arm, perpendicular. So the reference angle is 72. So in the first quadrant, theta is the reference angle, which is 72. And in the fourth quadrant, terminal arm is here, perpendicular to the x-axis. Again, the reference angle is 72. But in the fourth quadrant, it's 360 minus the reference angle. Remember, all the way around is the rotation for theta. Here it is. So it's 360 minus the reference. So it's 360 minus 72, which is 288. So if you have the reference angle correct, you get a mark. If you have 72 for first quadrant, and 288 for the fourth quadrant, give yourself 3 marks altogether. Number 11, find theta from 0 less than or equal to theta less than 360. Notice these are 1s and 0s. So when I see that, I look at the circle and I plot these points. I always keep these points. X is 0, y is 1. X is negative 1, y is 0. X is 0, y is negative 1. And remember that sine is the y and the cos is the x. So where's the y1? The y is 1, right at, and the answer is 90 degrees. Give yourself a mark. Where's cos? Cos is the x. Where's x? And negative 1. And the answer is right here. So that's 180. Give yourself a mark. Sine is the y. So where's y0? Y is 0 right here. So that's at 0 degrees. And y is 0 here, which is 180. Give yourself a mark for each one of these. Cos is associated with the x on the unit circle, or on the unit circle, cos is the x. So where's x 0? X is 0 right here, so that's at 90 degrees, and it's right here, and the answer is 270. So you give yourself a mark for each one of these, so that's 2. Total up the page out of 11. Hopefully everything is going well, because you have to understand these first videos to really work out the trig equations that we're going to do later on. In linear equations, degree 1, and quadratic equations, degree 2. Number 12, the final question, final page. Find theta 0 less than or equal to theta less than 2 pi. 2 pi is in radians. So we have to give the answers in radians. So let's draw a circle, and sine is 0. Sine is the y. Y is 0. X is 1. Y is 0. X is negative 1. Y is 0. So y is 0 at 0 degrees and 180 degrees. But we need to answer in terms of radians. So 0 degrees is 0 radians. 180 degrees is pi. So if you got 0 and pi, you give yourself a mark each, 2 marks. Cos is a negative a half. We want it in terms of radians. What we check to see what quadrants. Add sugar to coffee. And cos is the x, and the x is negative. Cos is positive in 1 and 4. negative in 2 and 3. So we draw it in 2, we'll draw it in 3. So in quadrant 2, there's the terminal arm. Cos is the x, so the x is the negative 1/2. That means the y is root 3 over 2. Hypotenuse is 1, so this angle right here is 60. So the reference angle for both of these is going to be a 60. And I do the same thing again in quadrant 3, terminal arm, perpendicular, and x is a negative 1/2. Y is root 3 over 2, but is negative going down. Hypotenuse is 1. The reference angle is still 60. So in quadrant 2, theta is 100. Oh, I got that one. This thought it was used out. It's not writing it. Hold on for a second. Got to get a new pen. Okay, I have a new pen. Okay, so it's 180 minus the reference angle, which is 60. So that's 120 degrees. And continue on. I got to remember I'm looking for radians. So let's multiply this one by pi over 180. So the zeros cancel, dividing by 10. 6 into 12 is 2. 6 into 18 is 3. So that becomes 2 pi over 3. And another way to look at it too is that 60 is 180, which is pi divided by 3. So that means the answer I have here should have a pi over 3 in it. Pi over 3 is 60. 2 times 60 is 120. And let's do this quadrant. And again, theta is, for the third quadrant, 180 plus the reference angle of 60. So it's 240 degrees. And 240 degrees, again, the reference angle is pi over 3. So this is going to convert to a pi over 3. So let's just check it out. Pi over 180 is what I'm multiplying by. Cancel the zeros and dividing by 10. 6 into 18 goes 3. 6 into 24 goes 4. So it becomes 4 pi over 3. 240 degrees multiplied by pi over 180 reduced down gives you 4 pi over 3. Again, the reference angle is pi over 3. So the answer for the rotation should be a multiple of pi over 3. Pi over 3 is 60 times 4, 240. Perfect. Give yourself a mark each if you have 2 pi over 3 and 4 pi over 3. And find theta if sine, cos is a negative root 3 over 2. But now we have to go between. It's telling us that I have to go, here's a circle. I have to look at the answer from a negative 180, which is here, to here. So that means if a negative 180, so that means I'm in quadrants 3 and 4. And if I think about cos, add sugar to coffee, cos is negative, cos is positive in 1 and 4, so it's negative in 2 and 3. So as a result, this is quadrants 2 and 3, but the negative 180 to 0 is right here. So overall, I must be in quadrant 3. So we'll draw the diagram for quadrant 3. Here's the terminal arm, here's the perpendicular. Cos is the x, so x is negative root 3 over 2. The y is a half, but it's negative in that quadrant. Opposite of half is 30. So I have a reference angle of 30 degrees. And third quadrant, theta is 180 plus the reference. So that's 210. And we convert 210. Oh, we don't need radians. I was going to do radians then because I did radians up there. I was thinking of doing here. So we got a 210. So a 210, but we got to have a negative. So we can take off the rotation right here is 210. But if I want a negative rotation, then I got to go 210, take away 360. So that rotation is a negative 150. So if you have the reference angle and you have a negative 150, then you get 2 marks. And another way to think about it, the reference angle is 30 here. But because we need a negative angle, so from here to here, that's 150. Okay? That's 150, and 30 is 180, but it's negative. So if you went this way, without subtracting like this, you would say that's 150, but it's negative, so negative 150 is the answer. Number 14, find all possible values of theta to the nearest degree. And we got sine. Because it's negative, I'm changing it to a positive. Now I'll get the reference angle is sine to the negative 1 of 0.3412. That means the reference angle comes out to be 20 degrees if you do it with your calculator. But we got to get the angles first. So let's check and see. Add sugar to coffee. Sine is negative, so positive in 1 and 2. So sine is negative in 3 and 4. Okay. So it's quadrant 3 and quadrant 4. And we got a reference angle of 20. So that means this angle right here is 20 degrees. So in that, and this angle perpendicular here, this angle is 20 degrees because it was 20 in the third quadrant. It's going to be 20 in the fourth quadrant. So it's the same reference angle. So theta in the third quadrant is 180 plus the reference of 20. So that's 200. And theta in the fourth quadrant is 360 minus the reference. So that's 340 degrees. But we want all possibles. So all possibles, all of them, is 200 degrees. Add on 360 n, where n belongs to the integers. And we want them all for 340 because, so it's 340 degrees. Add on 360 n, where n belongs to the integers. So if you got the reference angle, give yourself a mark. If you got 200, give yourself a mark. You got 340, give yourself a mark. You have these written out correctly, 5 marks in total. And remember, it's when you want all of them, the period of sine is the period of the sine graph. If you think about the sine graph starts at 0, goes up, comes down like that. So the sine graph starts at 0 and goes to 360. 1 sideways S. So the period of sine is 360 degrees. And number 15 is done first. And so if the period of sine is 360 degrees, then in radians, the period is 2 pi radians. The period of sine and cos is 360 degrees. Every 360 it repeats. But in terms of radian, it's 2 pi. Give yourself a mark. 12 altogether. Total up the page. Hope you have everything going well. And let's go back and find the first sheet. So your total of each page, and put it over 44. Divide 44 into the numerator, convert it to a decimal. Then move your decimal 2 places to the right to get your percent. And hopefully, your review on the first 11 videos, everything is going well. But you need to know how to do that to do the next series of videos coming up. And if you like what I've done, click the like button, subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com. And in that website, which is mine, you'll find more information about me, my videos, and the content. And that's the content that I have on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.